We're all quite aware of the SpaceX Starship, but have you ever wondered how powerful its engine might be? Well, SpaceX is developing the most powerful rocket engine, a methane-fueled full-flow staged combustion cycle engine called the Raptor, and it's so hard to develop, no engine like this has ever flown before. Today, we'll discuss everything about this SpaceX Raptor and find out if the Raptor engine will be the new king of rocket engines. To start with, we first need to understand how a rocket engine functions. Inside any rocket engine, there will be two tanks. One consists of fuel and another one has an oxidizer. When both these are mixed, they create a propellant which is burned to produce thrust in rockets. Typically, propellant flows through two kinds of combustion chambers. The first is called preburner and the second is called main combustion chamber. In the preburner, a small portion of propellant is combusted. In the main combustion chamber, the propellants are combusted completely to produce thrust. There are three different kinds of engine cycles any rocket engine uses. A staged combustion cycle, where combustion is done in stages, is where all propellant ultimately flows to the main combustion chamber, contributing to thrust. Opposite of that is an open cycle, where a portion of propellant never reaches the main combustion chamber. So you see why staged combustion cycle is more efficient. SpaceX Raptor is a full-flow staged combustion cycle engine, which basically means it uses both oxidizer-rich and fuel-rich pre-burners. It's called full flow because it allows full flow of both propellants through the turbines. The fuel turbo pump is driven by the fuel-rich pre-burner, and the oxidizer turbo pump is driven by the oxidizer-rich preburner. First, a clean methane fuel from the turbine circulates through the engine chamber and nozzle heat exchangers before reaching the preburner and turbine, thus removing the heat of combustion through a process called regenerative cooling. The fuel then reaches to the fuel control valve, which supplies fuel to both preburners. The oxidizer control valve redirects the oxidizer into both preburners. The partially combusted fuel and oxidizer of the preburners is then fed into the main combustion chamber. By the time both propellants reach the engine injector, they are completely in a gaseous phase. Then fuel and oxidizer are mixed inside the main combustion chamber and ignited by a spark igniter. Engine ignition for Raptor engines is handled by dual redundant spark plug torch igniters, eliminating the need for a dedicated, consumable igniter fluid. The combusted product then expands through the nozzle and provides the thrust required to propel the rocket forward. The use of separate turbines for the fuel and oxidizer turbopump reduces overall turbine power compared to a single shaft turbopump designed where one turbine must drive both pumps. Also, having the entire propellant flow through the turbines eases their cooling and creates a manageable thermal environment. Talking about the selection of fuel, until now SpaceX used RP-1 kerosene or hydrogen for its rocket engines, but this time it decided to go with liquid methane for the Raptor engine fuel. But why so? Methane offers higher performance than kerosene-fueled engines, with a difference in specific impulse on the order of 35 seconds. Although liquid hydrogen would offer an even higher impulse of 450 seconds, it comes at a much higher price. Another reason to consider methane is that SpaceX's ultimate goal is to develop a system capable of taking humans out to Mars. For SpaceX, methane makes a lot of sense. It's fairly efficient, it burns clean, and makes for a highly reusable engine. It burns relatively cool, helping expand the lifespan of an engine, which again is good for reusability. It's cheap and easy to produce and can easily be produced on the surface of Mars. Currently, two versions of the Raptor engine are being developed, a sea-level version of a vacuum version and a vacuum version. The vacuum version is similar to the sea-level version of the engine but features a much bigger nozzle, which improves efficiency in the space environment. This also enables the same turbopump, plumbing, and chamber components to be used in the vacuum version, cutting development costs and time. The vacuum version is optimized for operation in a vacuum outside Earth's atmosphere for the interplanetary insertion and in the ambient Martian atmosphere for retropropulsion ahead of landing. Starship will sport 3 of each Raptor variant. Starship will leave our planet atop a giant rocket called Super Heavy, which will be propelled by about 30 sea-level Raptors of its own. Something like this is hard to design and even harder to manufacture, and hence SpaceX is using 3D printing to develop many parts such as propellant valves, turbopump parts, and many components of the injector system. 3D printing reduces the production cost and enhances the thrust-to-weight ratio of the engine. 3D printing also improves the speed at which changes can be implemented, whereas the traditional method would require weeks or even months. 3D printers are the perfect machinery to allow slight tweaks in the design. Without this, it could take days to recast a component based on updated specifications. 3D 3D printing is faster and can work 24 hours a day. 3D printing is so fast that SpaceX recently announced the completion of its 100th Raptor engine. Now that we've discussed basic overview of the design, we can discuss a little bit about the specifications. Currently, Raptor is the only operational rocket engine to surpass the combustion chamber pressure of 330 bar. It has a thrust of 2300 kilonewtons and has a specific impulse of 350 seconds in the atmosphere and 380 seconds in the vacuum space. We won't be going into too many details regarding these as they are probably going to change in the future. SpaceX first discussed Raptor publicly in 2009. As of April 2011, SpaceX has not had many employees working on its upper stage engine. Let's check out what progress has been made for the Raptor till now. Raptor engines began flight testing on the Starship prototype rockets in July 2019, and in August 2020, a single Raptor engine propelled Starship prototype S95 to an altitude of 150 meters. This was the first flight of a full-size spaceship prototype vehicle. SpaceX performed multiple tests throughout 2020. In December 2020, the first high altitude was done with SN8 with 3 Raptor engines. An abnormally low methane feed pressure caused SN8 to fail its landing maneuver and be destroyed. After multiple attempts, the first successful landing of a Starship prototype happened in May 2021, when SN15 rocketed up to an altitude of 10 kilometers using 3 Raptor engines. During the test, each Raptor engine was shut off one by one as it fell back towards the Earth and neared the surface. Starship flipped from a horizontal position to a vertical position by igniting 2 engines and successfully landed the pad. Developing and maintaining such huge projects requires a lot of money. In 2019, the marginal cost of the engine was stated to be approaching $1 million. SpaceX plans to reduce the cost to $25,000. It also plans to mass produce up to 500 Raptor engines per year. SpaceX has been primarily funded by private investors, and the Raptor engine development too was funded exclusively through private investment, with no government funding until 2015. However, in January 2016, SpaceX did agree with the US Air Force to take US $33.6 million in Defense Department funding to develop a particular Raptor model. We can expect a lot more interesting updates on the Starship and the Raptor from SpaceX in the coming months. In the meantime, we can all appreciate how complex yet fascinating these engines are, and the engineers who worked on this amazing engine are downright brilliant. What are your thoughts on the SpaceX Raptor engine? Is it not the most advanced rocket engine ever created? And will Raptor engine help SpaceX achieve their goal of creating a colony on Mars? What other questions do you have about the Raptor engine? Let us know in the comment section below.